Good morning and good afternoon, everyone. Thank you for joining and welcome to this webinar for the launching of the first stable version of the SI reference point. This is a very important step towards the meter convention extending its role into the digital world, and thank you for being here. Today we will have three important talks by three special speakers. Dr. Cornelia Denz will provide us with an introduction to digitalization in metrology. Then Dr. Frédéric Meynadier will provide us with an history of how the SI reference point was developed. And finally, Dr. Jean-Laurent Hippolyte will tell us how to access the SI reference point. So we start with Professor Dr. Cornelia Denz. Cornelia Denz has been president of the Physikalisch-Technische Bundesanstalt, the PTB, the National Metrology Institute of Germany, since May 2022. There, she supports the development of modern metrology along the major technological challenges. She is a member of the National Academy of Science and Engineering of the Academy of Science and Arts in Germany, and a fellow of the European Optical Society, as well as the Optical Society of America. Dr. Cornelia Denz is a member of the CIPM and the chair of the Forum on Metrology and Digitalization of the CIPM. So please join me in welcoming Dr. Cornelia Denz. Dr. Cornelia Denz, the floor is yours.
Thank you.
So
Thank you so much. I hear from some people that there is a strong echo from it. Can you just give your voice if this has changed? And then I start my presentation.
Yeah, we can hear you clearly.
Also for the others, so maybe to check in the chat if everything is fine. So yes, I want to introduce you to the digital transformation of metrology. It's a sort of warm-up talk in order to get some excitement about what is coming afterwards. So if you think of digitalization, it's a continuously timely topic and that really needs some metrology. And maybe some of the articles that you saw in the last year saying already in 2024 that AI firms have already exhausted most of the internet's data. So there's a lot of data there, and it's about data quality. Then data is a foundation of trust inside cooperation. So trust and data is rather important. But there's also digital divides. There's frontiers in trades that have inclusion and non-inclusion. So it's also important to look at everybody in digitalization. Also, if you look, for example, at how far we are going now, networks, and especially also AI, are putting critical infrastructure at risk because they are doing so much activity that they may change critical infrastructure. So also something connected to real instruments. And then it says that business leaders should not ask about AI strategy, but ask about data quality. Also something to do with metrology. And now in the last months, you read that physical AI that is embedded in devices, is a market that grows immensely. And people say that in 2030, it will be the largest market of AI ever. So all this is connected on the one hand to digitalization, but it gives a glimpse that somebody is needed, like metrology, to give quality onto it. And so if we just look again at it, digitalization is really a once-in-a-century transformation that includes industry and society. And while most of us have technically done something like digitalization is just a strategic transition. It changes the way how organizations, industry operates, how work is done, and how decisions will be made. And this means that there's a lot of things. On the one hand, it affects everything: communication, education, everyday life in society, but commerce, production, services, and administration for industry. But there's a lot of benefits, of course. Digitalization can make things more efficient, save costs, advances automation in processes, have seamless customer experience, or creates data-driven decision-making. So a lot of benefits that also are urged for quality, maybe. So the advancement of digitalization, as it goes further and further, it needs reliability, it needs trust, and it needs safety. And this, of course, means digitalization needs metrology. And that is that talk about in order to do. And if you now look, what does it need from metrology? Then, of course, it's not only us, it's your whole quality infrastructure. It's about metrology, it's about standards, it's about market surveillance, and it's about accreditation. So, and since digital transformation includes data quality metrics are rather important. So paper documents don't have the data quality we want. Even a PDF does not have it, but it should something be more objective and not bind human resources. Between systems, you need to have an agreement on fair data and quality matrix across the system. But the last step will be to have really interoperability. That is the challenges between machine-machine communication or machine-human communication and automation. So interoperability is something that is really digitalization and not only digitization, and that also needs an approach from metrology. On the other hand, if we think of metrology, how we work now, also digitalization transforms our way. First, we think metrologically, because now we have to also consider how a digital unit, a computer, would think metrologically, and that changes our thinking on it. It changed also the interaction in our community, how we can interact together. And of course, there will be new metrological services, and the nature of these metrological services changes. That's what is the talk today or the webinar today. So the CIPM strategy 2030 that is shown here already said digitalization changes our world in the most fundamental way. It sets off a new era in metrology, providing the opportunity for fundamentally new concepts in metrology and new metrological services. On the other hand, metrology has an important role in ensuring consistency and confidence in measurement results in this new digital world. And that is what it's all about, that digitalization helps us to make metrology better, but on the other hand, also metrology has a task in order to look for trust and reliability. So in a way, like this picture from a company, we could say the future of metrology is digital, smarter, faster, and more integrated, but also there's something else. Typically, some of our activities in metrology, especially if it's about legal metrology devices, is sometimes in the secrecy, and it didn't matter a lot. But maybe instead of merely verifying quality, metrology is now poised to become active, a predictive force that drives continuous and smart improvements throughout the manufacturing process. So our services for industry may change a lot, and industry is also now requiring metrology to support them to go and profit most of digitalization. So that's why the forum metrology and digitalization has been realized. And this was the first multidisciplinary structure. It's not a consultative committee as the others are, but it overarches all the different topics and typically interacts strongly with consultative committees, with NMIs, with regional metrology organization and the BIPM headquarters. So our aim is also to harmonize processes related to digitalization from all the different stakeholders that are around in our metrology community. Then it acts as a body to exchange information and establish good practice, but also create synergies for collaboration also with other international organizations that go for the same way. For example, all the organizations quality infrastructure, but also organizations like 𝐝𝐨𝐬𝐿, like ISO, like CODATA, those that are looking for digitalization themselves, and working with them together means that we get strong from metrology to all other fields that are connected to quality infrastructure. So that's how we set our goals in Forum MD. First, of course, to look at a comprehensive, machine-actionable, widely applicable SI digital framework, which means that all the services that are connected to the SI units are then digital. And this goes not only from what we do today, from the SI reference point, but also to look at the digital services that we have, KCDB or other services, comparison, ring comparisons, all these can be connected to digitalization in the future. Then we look at data quality, not only FAIR principles, but also the quality metrics we want to assess data with. Then we look, for example, at quality certificates. digital calibration certificates, digital reference material certificates, digital battery passes, and others. How can we realize them and bring them to industry in the most beneficial way for everybody in each country? And then we look at more advanced things, look at conceptual consistency and interoperability by semantic approaches, look at AI. How can we get AI for metrological purposes and also get quality in AI by metrological assessment? And look at sensor network, which is a door from physical AI to computer-based AI, and what these systems are doing in metrology. So that is the idea of this forum, metrology and digitalization. So we have a lot of task groups, and just let me name these task groups, and then you see where we are going for today. So we create data quality metrics. That's the task group data quality and fair practices in metrology. We look at dissemination of digital certificates, as I just told you, harmonizing DCC, DRMC, and other certificates. We look at new services, and that is what is today about. Look at SI Digital Framework and the SI Digital Reference Point. But also, we look at interoperability with new semantics in metrology. We look at new tools like, this is the task group on sensor networks and the task group on AI. And then we look at the task group on sensor networks, and we share the ideas because we have a working group that brings together all digitalization teams of the different CCs. We look at in a working group how the different regional metrology institutes need help in order to develop their own digitalization strategy. And of course, we're looking for the future in our strategy team. So these are the different task groups that we are looking at. And the one we now today want to have a look is this development of new services and the first launch of an official stable version of the SI Digital Reference Point. So what is that about? The digital framework is transforming the SI into really a digital metrological tool in the digital world. So we want to ensure that the meter convention naturally extends its role as a globally accepted anchor of trust also for digital tools. So which means our beloved 7 SI units and all that is connected to it should go digital. And in the last years, we did a lot in order to adapt FAIR principles to data, make machine-actionable functions of the AI, and facilitate use of digital certificates. And this means the digital transformation of all important services of BIPM is going on. The addressing of digital needs from CIPM members and the NMIs is really observed, and we are going there, especially for the services of the BIPM. And we're fostering a digital quality infrastructure. So these 4 years already started to have the digital transformation of metrology in the way to look at a digital SI. And that's what we wanted to look today, but let me first give you also a glimpse in the future, because on the next general conference that is in October this year, we want to look on the further digital transformation of the global metrology system, because as I said in my beginning statement, it goes very quick. So the SE reference point needs to have a real framework that all services are interoperable being provided to you. But then maybe it's very important to have a conceptual consistency, because if you just make everything without being connected, without having the same consistency, then this is rather important to look at it. Standardized data exchange formats, standardized consistency and conceptual metrological standards. And then looking at really the advancement of artificial intelligence in a metrological way, and looking at the data quality assurance, for example, for large-scale sensor networks and complex sensor networks. So this is what we are looking for in the next generation. But now, today, we want to celebrate the success of the SI Digital Reference Point. So that is a central advancement, and it's about having a central development in development, to have the SI be now a digital reference point. So you can say it's a knowledge model of our international SI brochure, but much more. It's machine actionable, and it can be included directly in digital processes for those institutions that need the SI for their work, or for everybody that is here, for everybody that is working in metrology. So the SI reference point is the authoritative digital reference for the international system of units. And that's quite a point that's rather important to look at. And so now look forward to get more knowledge about it. How did that happen? How was the effort to come to such an SI reference point? And there were a lot of testing and beta versions, and how is it now that it's open for everybody? How can it be assessed? And so now Frédéric and Jean-Laurent will tell you about more how this worked and how this spectacular result is now open to everybody. Have fun now with these two presentations, and thank you very much.
Thank you very much, Dr. Cornelia. This is a very important view that you provide us about how metrology is pivotal to this global digital transformation and how we can benefit and how we need to contribute for it so it can be trust with quality. Thank you. To our participants, you can please, I forgot to tell you, I apologize. You can please post your questions in the chat so we can read them if you want. In the meantime, Alessandra Bendistinto has asked if we can receive the slides. This webinar will be made available at the YouTube of the BIPM, so you can visit there. If there are more questions to Dr. Cornelia, please go ahead and post them in the chat of this webinar. So I can give you a couple of seconds so you can write. And there can be also questions at the end of the webinar. So if there are no questions so far, we will continue with the next talk with Frédéric Meynadier. Dr. Frédéric Meynadier, he's a physicist from BIPM Time Department. One of his main duties here is to calculate every month the Coordinated Universal Time Scale, the UTC. But within the group that gradually formed inside the BIPM, and that was then joined by external experts, he participated in the early development of the SI reference point and to bring into the state that we can celebrate today the launching of the stable version of this SI reference point. So please welcome Dr. Frédéric, and the floor is yours.
Thank you very much. I will share my screen. I hope you see it. So hello, thank you, Christian, for a nice introduction, and Dr. Denz for the context of all this this presentation. I would like now to present you the history of the development of the SI reference point, why and how we did develop it. And I would really like to stress right now that it is a collaborative work. It's a teamwork between many people in the within the BIPM and outside of the BIPM, and it now has the form of an expert group that is included into the form of Metrology and Digitalization Task Group SIDF, but it also had earlier incarnation and a lot of contribution with many people, and I really like to thank on this occasion all people who contributed to the development of the SI reference point. So just a reminder, our starting point by doing the SI reference point is the SI brochure. And as you probably all know, it is initially a booklet. It is a printed piece of paper that did gather all the information about the SI, and that has been published for several decades now. And the first major step has been reached when it has been made available by the web. So I found this this image on the Internet Archive Wayback Machine, the state of the BIPM website in 2000, so more than 25 years ago. And you can see that the SI brochure is already in place there and already available as a PDF. So that was a major step, and I really want to emphasize that it was a major one, because making the text of the brochure accessible to everyone, everywhere, and instantly was really a major advancement, I think, for the diffusion of the SI brochure. So that's now how the website looks like. So you still have access to the SI brochure. Since 2019, so the 9th edition of the SI brochure, it is only available as a PDF file. It's no longer printed. You can always print it if you want, but there's no booklet for sale on that. It's available for free. You can access it whenever you want. It's under a Creative Commons attribution license in French and English. So it's a text with a lot of nuances, of subtleties, and so on. And it gathers all the decisions by the CGPM and the CIPM. The source of the SI system is the decisions, and the brochure is a compendium of that. And last but not least, it is identified by a DOI. You can see it here. That uniquely identifies this document and allows to make a reference to it. So it's a first step, and it's a very important one. But if you look at the possible modelization of all the digitalization steps that you must take to reach the fully machine controllable content that is the pinnacle of digitalization, then those are only the first two steps. The analog document was the booklet. The PDF version is a digital document. It's not yet machine readable and even less executable, interpretable, and controllable. And as you can see, the higher you climb those steps, the more machine readable it is, but unfortunately, the less human readable it is. So you can have the reference of this classification. It's one among others, but it's a rather spread one. So we had to make some choices because all the very intricate details of the brochure cannot be fully digitalized in a strict structure. So we made a choice not only to go to, I will go back to the first slide, to this machine-readable document, not only do that, but also aim at the higher levels of digitalization. And that meant that we decided to carve out the core of the SI brochure, the main pillars that constitute the essence of the SI. Those are the SI units, the SI prefixes, the defining constants that are tied to it, especially since the last revision of the brochure. A few quantities, not all of them. It doesn't aim at being exhaustive on quantities, just the ones that are in the SI brochure. And also the decisions concerning the SI, which are the source of truth when the SI is concerned. And a second very broad choice that we made was to use a semantic web approach. It came within the process that it would be a good idea to follow that. By the way, it's a quite old standard that has been provided by the the World Wide Web Consortium, W3C, almost as old as the webpage that I showed at the beginning, 2001. Interest of that is that it is an open format. It's an open standard. There's no vendor lock-in, and the files can be read by many tools, including free ones. And that fits the aim of the brochure to be available to many people and so on. So the result of that is that we decided to encode this database into knowledge graphs. It is an abstract concept that I will explain later. And by doing so, we know that we step away from a text that is easily read by people. The brochure is quite easy to read. And by doing so, we know that we have to make some conversion tools and some viewing tools that allows humans to still have an access to the SI brochure in its digital form. So just to say, I took that from the description page of the Resource Description Framework webpage, so RDF. That's the core of the semantic web approach. And you can see that it's based on a very simple, a very basic relationship. It's a triple. Triple because you have three objects, the subject, the predicate, and the object. And so the subject is linked to the object by the predicate. It's as if you say, okay, language will only be made of sentences with subject, a verb, and an object. So the simplest phrase that you can do, and it would be rather boring and rather monotonous, but for a computer, it is perfect because it is very simple and it is very standardized, and you can have as many as you want. A computer is never bored of seeing accumulation of triples. So this is the basic and only building block of the knowledge graphs that we'll use to constitute the SI reference point. And of course, the name of the game is as much as possible to use existing frameworks. But we have to define new ones. And how do we do that? I just showed this simple example. For example, for the SI reference point, we need new predicates. We need relationships that do not exist yet. So I took a very simple one. It's the fact that to each unit, we have a corresponding symbol. And okay, so we felt that we needed to introduce a new predicate called as symbol. And this can be described by triples that are referring to existing ontologies. And by doing so, we describe this new predicate. For example, we say it is something that is a data type property, and that already exists in an ontology that is called OWL, W3C Web Ontology Language. And then we can say that as symbol can also be linked to the fact that it is linking to a string, to a character string. And luckily, this already exists. The range predicate in the RDF schema tells us what it is made of, and the XML schema data type string allows us to directly refer to someone which is already understood as a string by computers. So by doing so, we construct a terminology. In terms of database, it's called the T box, T for terminology. And once we have that, when we have the predicates that we need to build all them, so this is only one example, we built many others, then we can make assertions. So that's the A box. We can say, for example, a particular unit as symbol, so we use this predicate, and the symbol is the letter capital N. And the good fact about that is that each predicate object, up until you have a basic type like a string or something like that, it does have its own URI, Uniform Resource Identifier. So we write SI as symbol, but in fact, you can replace SI by this URL that will give you a URI, in fact, that points to that. And this is how you build the ontology, by giving identifiers that are connected to other identifiers, and gradually you build that. There is a more complex example. For example, if you take the Newton, we already said that it has a symbol, so we define a predicate that is a symbol and we link it to N. But we can have as many triples as we want. We can have another one that says, okay, it's part of a special category that we define elsewhere, which is called SI Special Name Unit, because it's named like that in the brochure. And we can describe this and add some new triples. So you can see the knowledge graph building in front of you. We can define a unit product. We can say that is linked to the mètre, to the kilogram, to the second with an exponent. So building the SI reference point is identifying what kind of relationships we need, describing it as much as possible with existing ontologies, and then fill it with assertions about whatever unit is in the SI reference point, or whatever concept we want to push into the SI reference point. So you might say, okay, this is a way, a representation, a digital representation of units. It is for some part, but it's not a complete representation. It's only focused on the SI and what is in the SI brochure. It's not exhaustive from this point of view. And moreover, there are others systems that already exist, ontologies like UDT, implementation in existing systems and so on. Sometimes they provide additional reasoning and calculation. You can mix units and check the dimensions and so on. This is not what the SI reference point aims at replacing. We do not think that SI reference point should replace those existing ontologies, but it is a common reference for all the systems that get in touch somehow with units and representation of them or those concepts. And it is a way to bind them together. And it allows two different systems to say, when we say the second, we refer to the same one. We refer to the one from the BIPM. We provide a new URI for that. And this allows computer to understand that this is in fact pointing to the same concept and the same second. So if you want to see by yourself, so we'll have a very short look at the web endpoint, so the view of it that we have developed to see it for a human being. But you can also have direct access to the knowledge graphs themselves, serialized in JSON-LD or in TTL. This is on this GitHub repository. And for the release of the version 1, the stable version of the SI reference point, we also released the generation scripts that we have used and we have developed, so you can have access to the full chain that led to the construction of the SI reference point by looking at this GitHub repository. Also, there will be a more detailed description of all the process and all the concepts that we had, a longer version of this talk if you want. It will be in an article that has been submitted to Metrology. It has been a long time in the making, but now it has been submitted, and hopefully any day now we should have the referee report. So I hope it will be published soon. Stay tuned. For the future, we have reached a stable version by gathering a lot of feedback during the beta phase. There will still be feedback. In fact, I expect even more to come. And there will be other versions that will incorporate version after version 1.0, but we will keep, of course, this one stable for your use. There are two main ways to do that. You can either go to the GitHub repositories. They are publicly accessible. Anyone can raise issues. Anyone can participate to the discussions or just read it or see the previous merge and so on. It's also where you can see the development. And in a more institutional way, we also, of course, depend on the forum on metrology and digitalization that has been presented by Dr. Denz. And I've highlighted two of the working groups. One that is directly and explicitly meant to steer the development of the SI reference point, among other things, which is the task group on SIDF. And we also had, during the beta phase, a lot of feedback that came from the CCs, from the consultative committees. And these were channeled by the working group CC. And so it's also a point of contact that can be useful. So that's the end of the presentation. I just want to show you the website itself. Yeah, that's here. Okay. So this is one of the addresses that I've put on the slide. This is the view you have of the SI reference point. This is not the SI reference point. The SI reference point is encoded in all those TTL files. And this is the TTL is the knowledge graph as encoded. That's the SI reference point. But this gives you an example of how you can fetch the information from those TTLs and get tables that look like the ones that are in the brochure. You can have lists, you can have access to the unit expressions and Sparkle Assistant, and I think that Jean-Laurent will speak more about that. But you can see that this fully uses the links that you can make between the entities inside the database. So if you click on the Ampere, then you got access to the definitions, to the resolutions that are leading to that, to the defining questions and so on. I will stop there. Sorry, I already exceeded the 15 minutes. Sorry about that. But I will leave the floor to Jean-Laurent.
Thank you very much, Frédéric, for your presentation. This was really nice. Thank you. We have a question in the questions and answer channel. Shanai Rapp is asking, how stable are the persistent identifiers assigned to the SI entities? Can users rely on these identifiers remaining unchanged across future releases?
Yes, this is why we consider it stable. I think that the identifiers will remain stable for as long as we can, I guess. There will be new ones, but I think there will be backwards compatibility in the future versions.
Yeah, thank you very much, Frédéric. Thank you, Sinead, for the question. Yeah, the idea of these identifiers is that they will be persistent in time. So thank you for the invitation to submit your feedback. We really would like to know how would you use our SI reference point and how we can improve it. There is another question in the chat by Robert Walsh. Is there limits of use, for example, maximum polling rates?
So of course there is. They are hardware limited. However, I don't think the way that we built the SI reference point is that if you need rapid access and frequent access, then you probably are better off downloading the TTLs and using it locally, and then you can have as many access as you want. I don't think that the aim is to let everyone connect to the SI reference point each time you read a line on a table and check if the definition of the MET has changed in the last half hour. But this is something that has to be seen by use cases that can be submitted. But there's no hard limits right now. There might be if we see that this is a problem in the future.
Yes, thank you, Frédéric. Hugo Gasca from PTV is, and thank you, Robert, for the question. Hugo Gasca from PTV is answering its questioning, how can we add new entries in the measurements or quantity table?
You can always expand the database by yourself. If you want to have your own, if you need quantities that are not inside it, you can expand the knowledge graph by yourself. If you need to use quantities that are already tracked by existing ontologies, QEDT, for example, then probably you might be interested in using QEDT, which itself will be linked to the SI reference point. And I know that they already started to make the appropriate links and so on. The idea is that we think that, but that is not completely, that is something that has to be discussed in the digital forum, I guess, how exhaustive and how wide the covering of the quantities would be. If there is something that is obviously missing, the main driver, I think, will be the KCDB, and we will want to cover any quantity that is in the KCDB. But I think that the scope will not expand a lot further than that. But of course, it is a common decision. I'm not in position to say now what will be the decision. It will be discussed later.
Thank you very much, Frédéric. Thank you, Hugo, for the question. Also, you can channel your petitions through our GitHub issues webpage that Frédéric showed us. So that was the last question. Thank you very much, Frédéric. And now we go towards the end of our webinar with the last presentation by Dr. Jean-Laurent Hippolyte. Dr. Jean-Laurent Hippolyte is a principal research scientist for the Data Science and AI Department of the National Physical Laboratory, NPL, the UK's National Metrology Institute, where his research focuses on semantic modeling for measurement data. He has over 10 years of experience as a researcher in object-oriented design, optimization, distributed computing, and semantic technologies applied to interdisciplinary engineering and scientific challenges. He recently completed a 2-year secondment to the BIPM, contributing to the design and development of the SI digital framework from the ground up. Thank you very much, Dr. Jean-Laurent. The floor is yours.
Thank you, Christian, for the introduction. So now that Frédéric has explained what the SI reference point is, I will focus on how to use it. So the goal of this talk is to give a very brief overview of how one can browse, query, and automate access to the SI reference point. And every time we do that, we will be using the same underlying semantic models. We're going to walk through a series of increasingly sophisticated access methods. So starting with web browser-based exploration and ending with fully programmatic workflows. So the first practical kind of interaction with the SIRP I will present requires almost no technical expertise. No IT expertise. So before we even go to write queries to query the SI reference point knowledge graphs, it is often useful to explore the ontology visually. So with tools such as the GraphDB tool that is shown on the slide, and a tool like GraphDB allows you to navigate the semantic structure as a visual graph. So using that tool, you can quickly identify the concepts you are interested in, understand how they are connected, and discover relationships that otherwise might be overlooked or difficult to find in the textual documentation. For many users, and in particular for software developers, this is a very useful step to provide people with a mental representation of what the SI reference point is, before they can move on to interacting in a more structured way. This is a tool that is part of the SI reference point website that Frédéric showed earlier. And it's one of the most immediately usable tools. It's available at the URL shown at the bottom of the slide. So in that tool, users can enter their own unit expression using a very simplified syntax. So here, there's an example for meter per second. And then the services behind the web page will parse the expression. It will construct a semantic representation of the unit, and it will return a global URI that allows to identify it uniquely. And in addition, the parser generates a machine-readable representation of the combination of units, which allow the user to incorporate it directly in their own digital workflows. So it means the users can annotate datasets with authoritative identifiers that are not built into the SIRP knowledge graphs, rather than using their own convention or their own local text labels. For engineering applications in general, it means that it can provide stable, authoritative references that can be exchanged across different platforms, within digital certificates, between measurement services and customers, etc. The key point of this unit expression parser is that user can start generating this standardized semantic representation without needing to learn any specialized language. So the unit expression parser helps us create units and identify units or combinations of units. So the next step is to explore the SIRP knowledge graphs and discover more relationships among units, prefixes, and constants. And for that, we have to move to the SPARQL capabilities of the SI reference point. So this next level of interaction involves learning a standardized language called SPARQL. And the syntax of the language may not look familiar to you, but I think the basic concept behind it is rather straightforward. It works by basically matching patterns within a knowledge graph. So every query describes a kind of relationship template between subjects and objects. And here on the slides, the example is trying to identify which constant currently defines the meta and how to write its exact numerical value as a string. And you can note that once someone has created a useful query, it's a text file. It's actually a very small knowledge graph itself that can be reused to support research activities, engineering services, any kind of automated workflow. So in the slide before, I used GraphDB to run the SPARQL query, but you can also run the query directly on the SI Digital Framework website on the dedicated page called the SPARQL Assistant. Then the last level of interaction that I will present today is for users with software development experience. So for when they want to integrate the SI reference point directly into their data processing workflows. So they can use libraries. Here are two examples in Python using a library called RDFlib and another one called OurReady, which can retrieve SI reference point ontologies directly, maintain an image of the ontologies in memory, which allows the programs to do further processing. So these examples are it's a kind of running example. It's still retrieving the string representation of the constant that is defining the meta in two different ways. So one way is by just delegating the running of the SPARQL query to the local local program rather than integrating a remote one. That's the example below. And the example on top is actually using Python constructs rather than a SPARQL query to achieve the exact same result. So there are different use cases, or let's say not use cases, but families of use cases when you want to integrate the SI reference point in digital workflows. So there is programmatic mapping. So a Python script can automatically convert, let's say, data from calibration records into RDF or into XML and link every reported unit to the corresponding SIRP concept through its unique identifier. For semantic validation, so consider, for example, a data set received from an external partner where the unit has been recorded in a non-standard way. So if had they used the SI reference point, the inconsistencies in the data set would have been easier to identify. For automatic reasoning, so there are many different kinds of reasoning or inference that can be done over the SI reference point methodologies. But for example, one of them would be, is that SI prefix compatible with that SI unit? So, and the last one is for workflow integration. A calibration service or measurement service within an NMI could embed data quality checks directly into the data ingestion and data processing pipelines, and ensure at every step that the measurement record is aligned with authoritative SI concepts before distributing the data to customers, collaborators, or publicly. So as a conclusion, so in the talk we have looked at different ways to interact with the SI reference point. They ranged from simple visual exploration to unit expression parsing to SPARQL querying and integration into software workflows. I think the main message is that the SI reference point is not just a website or yet another ontology. It is foundational. It is a foundational digital reference, which is embedded into the broader SI digital framework. And as Frédéric has explained earlier, its objective is to make the SI information available in forms that can be understood not only by people, but also by software agents. So regardless of your level of expertise today, there is an entry point available. I thank you very much for your attention. This is the end of my talk.
Thank you very much, Dr. Jean-Laurent. This is very important for people to start interacting with the SI reference point. So in the questions, we have first question, if this from Raman Saravanan, if this recorder session will be shared later. Yes, it will be published in the YouTube channel of the BIPM. Thank you. Mazen Al-Rashed makes the comment that we have now linked the SI units and their derivatives electronically. Yes, thank you for the highlight. We have linked them digitally, hopefully in a persistent way. Thank you for appreciating the work, and we hope that it will make conversion and research easier. Thank you. Jean-Laurent makes the question if this can be hosted by other institutions to create mirrors or to allow for offline usage. This was answered, I think, I don't know if you can see the answer in the chat by Frédéric Meynadier. He says the knowledge graphs are made available under the Creative Commons license by 3.0 intergovernmental. So yes, in short, yes, provided that the usage complies with the license.
In fact, if I can say something about this,
please.
I think there is another use case. So earlier, Frédéric has mentioned a use case when if someone intends to make many queries to the SI reference point, then they might as well, host the ontologies locally. And another use case would be if there is an absolute need for security or confidentiality, that they could download the current files, verify the files with their own systems, and then host locally for themselves. The only drawback I can see with that is that you would have to watch the different updates of the SI reference point and manage yourself the update of your local mirror.
Thank you, Jean-Laurent. That's important. Thank you. You are being congratulated by Jean-Laurent. Thank you. It's great that you consider all levels of proficiency in your talk. We have a question from David Humphrey. The AI checking will pick up inconsistencies with greater reliability than a human checker, but many measurements require a series of supplementary measurements and corrections which are linked to the unique measurement systems in different institutions. Can you please briefly comment on this?
Is the question for me?
Oh. Yes,
Frédéric, yes. Okay. Happy for you too.
Okay. Yes, the goal of the SI reference point is to be the source of truth and something small enough that it can be checked and encompassed by a human. You can almost read the files. We did use some scripts to build them as reliably as possible, but in fact we could almost have written them by hand. And that's the intention. It stays a block of data that has not needed any AI or whatever stochastic approach to be built. It's really something where we chose every line, every single word, and we should be able to check it and to maintain it in that state. So in a sense, this represents a stable piece of data to which, in fact, AI can refer and use and do whatever AI does. But it's really the goal to have something that is as reliable as possible, and I think that's the sense of this comment. I hope it answered it.
Thank you, Frédéric. Thank you, David, for the question. Final question will be from 𝐵𝐺𝐬𝐿. If the turtle files are signed and semantically versioned, could either of you, please, Frédéric or Jean-Laurent, comment on that briefly?
I think not signed, but there is a mechanism for versioning. Yes. Of which, yeah, maybe Frédéric knows better.
Yeah, in fact, we are using the provenance ontology to have the semantic version of the the different files, so it is completely traceable. And there is currently a hash of the files to check that the content is untouched. Probably we could go a step further and have some GPG or better cryptographic signing, but that's something that remains to be seen.
Yes, thank you very much. So we go towards the end of our webinar. We thank our almost 300 participants, and thank you, Dr. Cornelia, Dr. Frédéric, and Dr. Jean-Laurent for your talks. Very important and very well given descriptions. And thank you, anyone, for joining us today. We hope you will benefit from this SI reference point. We are looking forward to see your use cases, and please reach out, file us issues, and let us know how we can improve for serving our community. Thank you very much to everyone, and happy day or happy lunch or happy night, depending on where you are.
Bye.
Thank you all. Bye.
Thank you very much, Yana, for the logistics. Bye.
Bye.